Tell you how to reach to the unicorn level by using deep tech. And to take this presentation, it's time for me to invite on stage the Enterprise Architect, National Payments Corporation of India, Mr. Arul Kumar. Everybody welcome him on stage, please. And as always, we'll be taking up the Q&As after the session. Thank you. Over to you, sir.
Okay, thank you. Today, I hope NPCI is a unique organization in India. So I think the title, what I was talking about is Standout. Standout is a unique uniqueness of people coming out and standing out. The next word is the disruptive. I think disruptive innovation is something like, if you look at companies, they start with the basic things and they move on to the upper level and move on, and finally they reach to the destination by taking out. For some of the examples are, for example, you take Cisco as a company. Initially, there was a company called Digital Computers which used to make bigger boxes and in the network, and Cisco used to make very smaller boxes, smaller stuff. And finally, Cisco used to capture the entire market of digital computers. And finally, there is no company called Digital Computers today. So that's what called disruptive innovation. That you start with small and capture the smaller market, and then move up and capture the upper market. We as a company today, started in 2016. At the time, if you look at the payments, it's like it's very minimal. Monthly you get 100, 200, and then you get 1,000, and then so means that we started with bottommost in the market, in affordable prices, like very low price, like per transaction, cost of the per transaction basis is very less. So which means that slowly you capture the market, and then using one of the thing is we used open source technologies, and then we captured slowly and we get to this stage. I'll be talking about how we achieved this scaling and performance with the different principles and models that what we have. So what makes us unique? Being a company as NPCI, what makes us unique? It doesn't come just like that into the market. We have some of the principles, and we usually check those principles against each of the features or products that what we do today. And I took one of the four key items in the projects, like for example, principles, standards, and platform and ecosystem. These are the key elements that for NPCI to sustain in the market. So the principle is like, as I'm talking about the deep technology, I'm talking about the principles that are applicable to the technology areas. So two important principles that today we have. One of the principles that what we have is design. That means intellectual contracts. Means before you start the project, what are the intellectual contracts that you will pull for the project? Which means that while you design or architecture the project, there are different contracts that we need to do at the architectural level. That's what one of the contracts that we do. The second is the implementation contract, where once the project started, you will have a different contracts. That's what it's all about. I'll talk about a little more details in the upcoming slide. And the standard wise, I think the first we started with a payment domain model, retail specific domain model, which you look at the specification today. The specification has different functional blocks, which is very unique to us. Those functional blocks are, we have those functional blocks, and that is the foundational blocks for a retail payment sector. And each of the retail payment sector, then we build a different service. Today we have 100 plus services are available on top of those all models. The basic is the payment model, information model that are available to us. And with that, we are able to add more and more services today, and we have added many services today. Even future also we'll be able to add services. Another thing is we started building platforms so that the services can be easily built. And the platform is because when business comes and asks us, can you build the service in 3 days? Can you build the service in 1 day? So the services, what we need to make it, the services more configurable. So, and interoperable, so that the services can be doing it. So, I think that the data and all comes in picture. So the other important aspect is, whenever we do a platform, if we are not doing a kind of a service back to them on the other side, for example, in the bank side, enabling banks, for example, giving common SDK, giving some sort of a stuff, that is very important. Otherwise, a bank will not understand how do we scale the system and all. So we'll be talking on these lines a bit more in details on the coming slide. So what are the principles that we have today? That we want to build every software in NPCI as open source. Means all the software we build in the recent platforms, everything built on open source. There is no commercial software involved, and we completely removed all the commercial items from our side. So which means why we need to go for open source? Open source provides high flexibility, because we need today high flexibility. Otherwise, we will not be able to achieve the scale what we have today. Because some of the commercial software, if you want to have a scaling and the cost is high, and scaling also it's difficult, even though they are commercial, but still they cannot achieve the scale what we would like to, and we have experimented those all steps. So very important is we want to be open source because it provides flexibility, and also the cost wise is very less for us to do that. And the second important point is we want a specification or a model which is very unique across all the products. And we are slowly moving to a direction that one time that we will have one specification for NPCI, so that when somebody comes to NPCI, here is the specification that we would like to. One of the examples today we are pushing IMPS and APS product back to the specification is the reason that we build a platform that on top of that those products going to be deployed. And the other important point is more highly technical stuff, that event driven means whenever there is an incident happens, immediately we want to have that to be propagated to the next guys, so that we can take some advantage of doing that. The third important is we want to be no affinity with any of the layers what we build today. For example, there is a layer bank, there is even technology layer or business layer. Between the layers, we don't want to have any kind of affinity. Means with that data only this will work. So that we don't want to build any affinity between the data sites, and we want to have the data distributed across multiple machines in different sectors. That's why we want to do it. And anyway, we are working on the data loss. We will have data loss, but we want to limit the data loss to the closest manner what we would like to. And every data that what we pass between two different systems is very important, because we want to have that highly secure and integrated. Because whenever your data pass from one terminal to other terminal, it's very important to be sure that people will not change the amount. For example, if a payee has payer has mentioned as 50 rupees, and I change the data from one terminal to another terminal, then the 50 becomes 100. It's a problem. That is what we call it as data integrity. So we want to be sure that every time when you pass the data from one terminal to other terminal, be sure your data is highly secure and integrated, so that you will be able to do that. And one of the things is more of a resiliency building. Every software layers or hardware layers, we want to test for resiliency. When we make the hardware fail or make the software fail purposefully to see what is the reaction. Do we have data loss? Is there working as expected? Is the software is atomic? Something, those are all similar. And I think the event driven and real time is very close to each other. And the third, the final two important aspects are, we want to be layered. We want to be layered on every layer. Each layer for example, if there is a in front end layer which takes the data from bank, or there is a back end layer which takes the data back from database, also we want to be sure that those layers are very separatable. Because for example, we were in Postgres previously, now we are in Cassandra, because the change is very easy for us. Moving from one data source to another data source, or moving from one database to other database, is very easy, because we have done the design and development on those layers. And we want to be sure that every use cases or test cases fully automated. I think we are on the way to make it 100% on each of the layers. I think this one of the use case, where are we today and how we are moving towards in open source, that's what it's all about. We have principle that we talked on the previous slide. And there are three different contracts which also talked about it. We talked about architectural contracts, which is like zero data loss, active, and we want to be sure that the site works even the scalable, elastic. For example, one instance to other. Those all are steps. And the second is the quality checks. For example, code quality, design quality, and the other one is the security stuff. And we need to be sure that every application we build on security and other stuff. And the middle box what we are talking about is today how we are earlier, means yesterday, how we are today, and what we do for tomorrow is the one that we are talking about it. First one is we started using open source frameworks, and slowly we are able to customize the open source frameworks. Means we are able to do some changes to the frameworks, and we are able to use the frameworks inside our premises. And third is we create frameworks, and how do we distribute to the ecosystem, make sure that the ecosystem uses those frameworks to distribute it. And how do we do the projects? I think we have only three options while doing the project. One is use the framework to customize it, only customization, do make some changes on the parameters and everything. And then second is you do some customization and you do some new frameworks and tools. That's what we call products and features. So when we build the platforms, what we wanted to be sure is we wanted to build the platform with the features, like UPI is one feature, second is the IMP is another feature, and IMP is another feature. So that the platform can capable of adding more and more features based on the business requirement. That will be more, that is what the direction will go. We are planning to be on the build state, where we will be delivering frameworks to the ecosystem, to help them out to build new frameworks or whatever frameworks that we use to scale ourselves, that we will be distributing, that we have frameworks and tools, we are using it.
Question?
Yep, sure.
No, any kind of a system design you are able to share, and also talk about factors that led to certain technology choice?
The choice, for example, the choice we led initially, we were using Postgres initially, and we have the choices with Postgres. A single instance of Postgres will support a certain amount of TPS value, or the concurrency for Postgres will be up to 200 plus concurrency. Means you are able to take 200 concurrent connection Postgres, because Postgres has some limitations. Postgres creates the connection. If you look at more deeply into that, it will create a process inside your Linux kernel. So you will not be able to create more than 200. Your OS become unstable. So the choice is till up to some extent of TPS that you are able to use Postgres. For example, you want to have a system which supports only 500 concurrency, then obviously 500 TPS transaction. Obviously, it will be able to support it, because these process, it will return in milliseconds. So you will be able to have the pipe of 1000 TPS is the max that you can do. For example, what we did is we used Postgres for different Postgres instances and threaded the data across it.
So you use Cassandra for distributed writes?
Distributed writes, yes, obviously. And we don't write very distributed, and we also use in-memory processing. We don't write while we do the transaction, it is completely in memory. Means we don't even write to any physical disk. We will have a backup in our middleware. Kafka will use to write it in middleware, and we will push the transaction back to Kafka for a safer side in case anything goes on. So there's trade-offs are everywhere. While we select the framework, we want to be sure that the frameworks has backup and everything. So this is, what we want. We have built the standards. So why we have built the standards, right? For example, if you look at our specification, I'm sure most of you guys read the specification. If you look at our specification, there are a lot of functional blocks will be available. Payee block, payer, and you will have a roles block, and your transaction. So those are the fundamental small elements we build, and that are more relevant to the larger service building. And each of the service what we build is we have a space to be sure that the API is highly integrated, means integrity of the data. And then we have provided a mobile SDK, and we are checking every transaction through fraud. These all are what the communication what I want to make, that everything is been in rule based, means this is what the specification, this is what you should do, that been drafted clearly. That is what we were mentioning here. For example, every data is sensitive. We have a rules that saying that every sensitive data has to be encrypted, every sensitive data has to be abstracted out of the people. That been clearly dominated. And I think the model of asynchronous communication is what makes us most successful, right? Between system A to B is synchronous, because that's what anyway communication happens. But B to A again, it's not a synchronous communication. It's a synchronous communication. So I think I've given some high-level view about how we do, the transaction. We start with the PSP app like Beam, or maybe any app like Axis or ICICI, and they have their own PSP which actually sends the messages back to UPI, and then UPI process the data, and then again it sends to the bank, remitter again, and it sends to the beneficiary, and then comes back. So this is the online cycle of it. And then once that completion, and once the transaction been completed, the back office started processing. Means while I think I want to update that back office is not it's not a batch mode back office. It's a near real time back office that we aggregate the data on real time, and we have the settlement ready at every point of time. Like we can do that settlement on every 15 minutes, and then we can deliver that back to RBI and banks. The one of the challenge what we have, banks today require typical lot of files and everything. So that's the challenge today, and I think we will continue to work with banks to reduce the amount of reports that we generate on the fly. So thereby our settlement becomes more easier on that.
Can you clarify on the asynchronous part, because since the app locks when you initiate a transaction, you get an indeed asynchronous.
So that's
Waiting to complete.
Yeah, that's a part of PSP task. What PSP does when you send the transaction from app to your PSP has to hold the connection. It's not our responsibility to hold the connection. So what the point is, once PSP sends the request, we give an acknowledgement saying that we have received a request, and then we are done. That's it. Then we will start another process to go back to the depends on the API service. For example, if it is a pay, we go to the payee guy to verify account number IFC and get the IFC. And the third is once they also acknowledgement. I send the request, they give an acknowledgement. They take time. They take a few
Is that all a message oriented?
Yes, sir. Yes.
All message oriented.
Yes, everything is message oriented.
Okay.
So I think some of these we push the data to monitoring on the asynchronous manner to be sure that we get the real time update on the transaction. Second is also we have pushed to analytical to get our fraud model updated on the fly. So maybe we have a batch process continuously runs to take the data for profile updates for the people, so that the profile update happens to the when next transaction comes in, the profile data updated, so that when the profile data pass to the model, then we get a better scoring. And we also have a rule-based engine for fraud and monitoring. So this is a very high-level view of how you can see that the analytical data pushed to FRM, profile update, monitoring. I think we use for ELK stack to monitor it up. And I think we also have an important fact that today I think I'm not sure all the PSP apps has a real-time dispute management, but today Beam has, in the transaction go to deemed status, you can go back to Beam app and after 15 minutes real time you can create a dispute. Like you can say that my fund is not received, can you check the real status? So some cases it can automatically resolve your dispute, and some cases it has to manual approval is there, but there are liability issues are there in terms of returning the fund back to the customer. But this is something like very interesting because customer fund, they can check the status right away after the transaction comes, in case the transaction goes to the deemed status.
And can you just explain very briefly about the fraud detection capabilities on UPI, because I thought it was only for RTGS and
No, we have a system, we build a in-house system. We constantly update, we create profile for customers and merchants, payers, and we keep them every day updated. And that profile being fed to the models and fed to the rule engine every time when a transaction. For example, a transaction comes to our system, again we get an asynchronous message back to the forum saying that for this transaction, the profile is, who is the profile, and take the profile, fed to the model, get the score, and return back to the banks. That score will be used to determine to decline or proceed further. So that we have the capability, and all the products are using more or less with the same. For example, FRM is integral part of every product. It's not that only one product is there.
only for high value payment products.
Even for every product, because this is sometimes your lows, people also can do the fraud, right? For example, every 100 rupees somebody guy was trying to push to that volumetric attempt they can do. Sometimes they can they can sometimes spoof they can, there are a lot of ways that one can do the, fraud. So all these are.
You pick up the profile and you just provide it as supporting info to the bank to decide.
Yeah, some cases, and some cases we reject ourselves, right? So these all are, there are rules which are agreed by all the banks, we reject very straight away. Some of the cases, banks and assets a little different, and there are the rules we customize per banks in our process. Some banks will use the default rules. It depends on what we configured to the system. We can decline or we can push. We ask the final how we interact with the banks. Some banks also have their own forum systems, right? So, and we also take the feed from banks in terms of frauds and other things. So we take the feed from banks to understand how this, so that our models and everything, we mark this is the fraud fed to the system, the model can improve. So that's what. So, this is something like what we do today and how we want to envisage in the next couple of years from now. For example, we have created, four platforms, and some of the platforms in evolving stage, and we will able to complete in next few years. So one of the things is the UPI platform that we call right now is a centralized processing platform, which means that every transaction comes to us, and we do the process, and we keep everything with us, and then we share the result back to all of us. And the other platform is Beam. Like, we want to have a mobile platform where whatever mobile application that we do today, we want to keep it with that platform. And the other is the decentralized, processing platform, which means data with everyone, and we keep the data everywhere so that the data inconsistency is not there. There is no reconciliation of data is not required. The third one is we are building an open AI platform, which we wanted to be sure that a community-driven open AI platform, which could be the model being built by community, and the model can be given to us, and we can run our model on our side to see that which model is better, and we give we say the user, this kind of a open community-driven AI platform. What is the problem? We give the data back to them, so we expose the data, and they can define the data set what they wanted to do, and they take the data and they can train that, and they can give the model back to us. And because sometimes the model requires a lot of physical resources to run, so once they say this model is good, we will keep them. If the model scores better, we want to keep the model to run our production. So this is some sort of a scoring we will do. Model 1 from X guy is better, and model 2 from X guy is not good. We will keep the kind of ranking out of that. So these are the four, and we were planning now, and tomorrow we will improve. That's what the horizontal bars are, right? How we want to construct ourselves. We want to have a commodity hardware. Anyway, that is same across all the platforms. It doesn't matter which platform uses. So we have the same hardware for every platform. So fundamentally that is same. And anyway, the option for future, what we are looking for is, we want to look for Kubernetes with the bare metal servers, which means that will give you a better performance than running a virtualization, or a bare metal with application, which also has a little challenging because that has limitation of how to scale it up, right? That is also challenging for us.
Today you use VMs quite extensively.
No. For EPA we use bare metal. Performance we normally use bare metal. So I think the choice for us is NoSQL and SQL is there. I think SQL RDBMS based database, we are reducing our footprint. I think we don't want to have because that is a problem of the multi-site or active challenges are there, which means that those challenges very tough. You cannot replicate the data. Some database support, some database doesn't support. So NoSQL, and we opted for Cassandra. That is what the good database that can distribute to multi-site. And I think middleware we have limited stuff, and I think we are looked at Kafka and Pulsar to be sure that that is what middleware for all the applications. So that we want to be sure. The reason we are putting this horizontal bar is we want to be sure those frameworks and the adapters what we build on the frameworks also remains useful for all the platforms. We don't want to be sure that take this small step, do for one project. The reusability becomes very challenging for us. So and the difference starts from the frameworks level, because for example, we wanted to use only 3 languages. So for right now, Java, Go, and we want to use Python for machine learning, and go for some of our stuff. So we will go towards these 3 languages. Whatever frameworks and adapter we want to build, or the components that we want to build, we want to be sure that it's reusable across all the platforms. And in terms of technology, now in terms of business it is a little different, but in terms of technology we want to be sure we build some frameworks on top of Go, or we want to build on some sort of Python or whatever maybe, we want to stick to that. And wherever we do today, service exposure, we want to have one service for every, means one service definition will be there to assess any service in any of our platform, so that we will have a uniform specification across all our products in the market. That is what this is kind of a model that we will be doing on our side to get this done. So our focus is to get that high reusability across these layers. Layers are very separate, so that one layer cannot impact the other layer. Those all things are very important. So for example, every layer we will have a kind of a specification, right? For example, middleware uses RVMS, then there is a specification. Framework uses middleware, there is a specification. Unify, the Java, the application layer uses other layer, that's also specification. So that, suppose Kafka doesn't work tomorrow, we will go to Pulsar. Our application logic should not impact anyway, so that the UPI will run as good as it is today. That is what our logic part of it. So I think this is to just represent how we wanted to be, or how we are today.
On the previous slide, any framework you want to talk about, or you picking up what I'm interested in your learning, because they would say a lot about your high volume transaction handling.
Right. So I think what we build, we normally take the frameworks and we shred the data across, because open source has limitations in order to shredding the data. Because why we need to shred the data? We need more concurrency. Like for example, one physical server has a limitation. There's this much CPU, this much process that you can create. So if you want to create that much scale, you need to parallelize. How much parallelism you can create, that much is good. So parallelization requires distributing data, and you need to have the copy of the data for replicating the data. So that whatever framework used today, that is what we do today. For example, use take Redis, distribute, make copies of it synchronously or asynchronously based on the configuration we drive. So I think that philosophy applicable to all this software. This diagram is just to reflect wherever we want to have an instance, we want to scale it horizontally, so that with stateless horizontally, no affinity, because one service down, there should not be a data return to some disk on the local disk, which is problematic for us. So everywhere we want to go horizontally without shredding data. Anyway, the data will be available on another node. It automatically started processing it, it goes on. And these horizontal scalability will help us to, even it goes to billions also, or even it goes to millions also, or trillions also, it will be useful. Today, the kind of knowledge what we have to build the system is, we want to be, the base is set up now, principle wise, or in terms of how we need to build the system, that is there with us. So, it doesn't matter like what we committed on the, like billions. Already we are in billions. We are able to create our system today support billions of transactions. Sometimes we get hit up 10,000 TPS per second. So which means that 12,000 TPS is billion per day. So we are capable of delivering that much today is available. So trillions is doesn't matter, for us. Maybe we need to be sure this affinity of data and stateless is the key for us to scale further, and I'm sure that we will be able to scale even a trillion transaction comes to our system also. With that, I'm closing session. Any questions anybody has, I will happy to answer it. Hi.
In your slide, you mentioned you're using German.
Right.
So it's like we're gonna have much bigger server farm.
No, we won't. We will be. For example, you have you imagine that you have 5 racks, right? You have 5 racks and you have servers. e-server does not run one instance of application, right? So we will assemble in such a manner that we effectively use the hardware. So it does not one big server we will use one.
That I'm aware. I'm just trying to understand. So what is the landscape looking like from a server farm perspective? Sorry. So what is the landscape looking like at this point in time? Let's say you are having 1 million transactions in an hour, or maybe a little more.
We have today in an we at least 6,000, 7,000, and 730 to 830 we will have around 6,000 to 9,000. Sometimes we have seen this. Okay. So this is what the transaction per second, and typically I think at least till 10, 11 o'clock we have seen around 4,000 somewhere, right? I know maybe earlier we used to see very low, but nowadays even now 11 also we have a lot of transaction flows are happening. That's what the landscape. If you look at standard deviation curves, I don't see any zero transaction, because throughout the night we used to see at least minimum 500 to 1,000 transaction was flowing to the system, and only in morning it's like morning 12 we will have some peak, and evening 7:30 we'll have full peak on that.
I mean, I'm just trying to understand the benefits of going with the bare metal deployment versus on-prem. Sorry.
It's on-prem. We have a data center.
Versus
virtualization. We want to do virtualization, but the virtualization has a typical problem of introducing latency. We have a couple of our products runs on virtualization. For a higher, for example, if you virtualize a particular physical server into 10 different virtual machines, and what will happen is you will create a typical virtual switch on top of that, and you will have a real NIC card will be there. So these latencies are introducing considerable latency to the system. So otherwise we have to go one-to-one level, right? One-to-one level. Sometimes do you want bare metal or do you want VMware? It's a trade-off, right? For example, bare metal performance very good. Right? We get nanosecond response in our system, right? For a typical write happens in nanoseconds from Redis to our system. So that performance is the key for us today. That's what UP we are able to give. I think less than 98% of the time we complete the transaction in less than a second. So only few seconds because of the ecosystem, banks and other things, we get a little bit of. Otherwise, we ourselves never take anything in seconds. We take all the processing in milliseconds only. All the thing, 5 times if you send a request to us, we give an acknowledgement in a few milliseconds, 3 or 4 milliseconds. So we never give. We always monitor. We have SLAs today, like how many milliseconds that each leg message-wise processing has to be done. So that been even measured today. So that is the performance. This is a trade-off, right?
So I'll come to the next question. Sorry. So in your slide, I saw the FRM was first the analytics part. So the feed to the fraud detection was after the. So can it not be a real-time feed?
A real-time feed. Actually, I'm in the picture that I mentioned, but it's a real-time synchronous, like for near real-time feed. I cannot say real-time feed means it's a synchronous communication, so I cannot say that. Synchronous is blocking call, right?
Correct.
So
I'm not going to block.
So asynchronous call. Definitely it is a near real-time. It's not like, it's not that we are posting it. Sometimes we do a profile update in a different manner and post back to the foreign system. I just represented.
More of a callback, right?
More of a callback. Yeah, right. More of a callback.
Thank you.
Welcome.
So you mentioned your transaction time is in milliseconds, but still the PSP has to wait and wait for the status, or
wait for the status.
So does it waits on a webhook, or you have?
No. PSP we won't only Beam PSP. What we do is in Beam PSP, we hold the call. We hold the call until a response back. Means for example, when customer like from app that you are sending a request to the PSP what it does, like it will if you look at there's a round that will come, right? It means that I have just hold the call. So while holding the call, the PSP parallelly create another process, sends the request back to UPI. So when UPI acknowledge it, immediately in millisecond you get an acknowledgement back to PSP. Remaining all UP will take care. There's a message system that we will send requests to retail guys, like a payee guy to get the details, and we send the remitter success and send the beneficiary success, and then finally we give once remitter and beneficiary that those guys are sent confirmation, then the other message goes back to the PSP saying that your transaction complete. By the time that guy will will stop the thread and move forward with the transaction to customer. This all happens in less than a second. I think, maybe there are many messages, like 12, 13, 15 messages. Sometimes 18 calls will be happen between the system.
So in your technology stack, you mainly all work open source mainly, right? So do you use any API gateway? Do you have any?
We have an internal API gateway.
What is the name?
We build on top of Spring Framework. We build a API gateway on top of Spring Framework, customized for our needs, and then we move forward.
So it's not exposed to other people.
It's not means you mean to say as a
If I want to use that gateway, can I use it?
No, you can't. We are. I think that's one thing I told. We were planning to see that could be open sourced or given to community back. We are working on we are working on to see how we can put this useful stuff what we build for scale this up. We have a plan, and we will be seeing that maybe in future we will be seeing whatever best that we have created frameworks and tools could be available in the open source community to make them build better, or you use as is. It will be there, not immediately, but it will be there.
And you mentioned you're going away from RDBMS database,
right?
Mainly because of, I guess, its performance.
Yes.
So you switched to NoSQL database, right? Do you not have the same challenge in NoSQL databases?
Sorry, come on. NoSQL database. Yeah, there are challenges in NoSQL. It doesn't mean that see RDBMS. If you look at atomicity and integrity of the data, it always take care, right? That it gives you a consistent result for you. If you go for a NoSQL database, you have challenges there, right? So what we do is today we use caching mechanism, right? We don't update data because all the transaction processing is to be caching in the front end layer in a more staggered manner. So you get atomicity, your data consistency will be there, and the data. So what we do for the NoSQL, once the transaction completed, update that data back to the NoSQL in asynchronous manner, just to keep the source of data, like source of truth data. So that means it goes asynchronous. So the need, and from the database, we use for the check transaction, the backend processing, which is not so real time, right? So whatever needs of near real time, or the back office steps, or processing, batch processing, those all will be done from there.
So do you have multiple instances of this database? Or?
Yes, obviously.
And how do you sync up data between all those?
For NoSQL, for example, Cassandra, it has an internal gossip protocol which syncs the data, and we give, it depends on your own needs, right? For example, how many sync writes you want to do it on Cassandra or any database. Same for NoSQL. You want to write for 2, or you want to write for 3. How many times you want to write sync, or how many times you want to write async? It's a configuration. So we use basically 2 sync and 1 async write. So means while I write the database, I want to be sure 2 servers it writes in a synchronous manner. 1 server it writes in a asynchronous manner.
All right, so we're done with the Q&A because we have to start our next presentation, which is of course the last one and an interesting one. So for now, thank you very much, Arul sir. Everybody we have a round of applause for our speaker, please. Thank you.